Welcome to Seyon Busy Made It Easy channel, the only channel exam fears in Ghana. We are going to have a lesson on HCF, which is highest common factors, for which people also call it greatest common factors. So they are the same. This is a situation where you find the highest and the common factors in a given number, two or more numbers. So we know how to find factors of given numbers. So this one, the easiest method we normally use is using the prime factorization method. The prime factorization method, which is using the factor tree. Now, to use the factor tree, always remember that when they give you a number, like maybe 4, and you're using the factor tree, what numbers do we use? The numbers we use, make sure that one of the numbers you are using is a prime number or prime factor. So when we talk about the two numbers you are going to multiply, one of them should be a prime number. And the first prime number we have is 2, because the factors of 2. So we have 2, we have 3, then we have 5, 7, 11, 13, 17, and following. So you always use two numbers to multiply to get the number on top. So this one, the numbers we can use is 2 and 2 itself. But when you multiply this by this, then you get this. Now, assuming they give you a number like 8, you try with 2. If 2 doesn't work, then you use 3. So here, because 2 can work, is 2 and 4. This is a prime number. This is a prime number already, so we break down this one to using 2 and 2. So the prime factors of the 4, we have 2 times 2. Then that of the 8, we have 2 times 2 times 2. When you are picking, we pick only the prime numbers. Yes. So here, when they ask you to find the HCF of the numbers, you look for the common numbers. The number, you select the number of common numbers we have. So 2 is here, 2 is here, so you can say 2 is common. Then we have another 2 here, another 2 is here. So you can say that one 2 is common. So you multiply them through. The 2, this is 3 here, and this is 2 here. So we can't say they are common again. So the ones we have, you multiply them to get 4. So we can say the HCF of 4 and 8 is equal to 4 because of what we have here. So this is how we find the HCF of a given number using the prime factorization method. Now let's take a question on this. So we have to find the HCF of 12 and 36. The HCF of 12 and 36. So we use the prime factorization method. So 12. The prime number that we can use with other number is 2. 2 times what will give you 12, which is 6. And this is the prime number already, so we come with a 6. The prime number we can get is 2. 2 times what will give you 6, which is 3. These are prime numbers, so we leave them. So now 12. The numbers we have are 2 times 2 times 3. Now let's come to 36. 36, we can use 2, we can use 3. But 2 is preferable, the first one. So 2 and what will give you 36? 2 and 18. Now with the 18, we can also have 2 and 9. Now with the 9, we can't use 2. 2 cannot multiply the number to give you 9. So the next prime number we use is 3. 3 and what? 3 and 3 is off. So these are the numbers we have. Now with the 36, we also have 2 times 2 times 3 times 3. Now when you finish and you multiply the numbers, you see that you get a 36. 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. Now here to 2 times 2 is 4. 4 3 is what? Is 12. Now we are come to find the HCF. We have 12, which is 2 times 2 times 3. Then we have 36, which is 2 times 2 times 3 times 3. We are going to select the HCF. Now 2, here is common, here is common. So we write 2. We have another 2 here, another 2 here, times another 2. Now the 3, 2 is here, 1 is here. So the common one, we have 1, 3, and this one, times 3. So 2 times 2 is 4. 4 3 is what? 12. So we can conclude by saying therefore the HCF for 12 and 36 is equal to 12. So this is the HCF for 12 and 36. So this is how we select the HCF for a given number. Let's take another question. So we have found the HCF of 54 and 72. So 54 with a factor 3. Can 2 work with 54? The answer is yes. So 2 and 27. Can 2 multiply any number to give you 27? The answer is no. So the next prime number is 3. 3 times 4 to give you 27. 3 times 9. Now 9 we have 3 and 3. So with the 54, you have 2 times 3 times 3 times 3. Now let's come to 72. Can 2 work with a 72? Yes, it's 2 and 36. Can 2 also work with a 36? Yes, it's 2 and 18. This one also gives us 2 and 9. Then we have 3 and 3 again. So 72 is also giving us 2 times 2 times 2 times 3 times 3. So these are the prime factors of 54 and 72. Once again, we are going to select their highest common factors. Now, with a 54, we got 2 times 3 times 3 times 3. Now with a 72, we got 2 times 2 times 2 times 3 times 3. We are going to select the highest common and factors. Now 2, 1 is here, 1 is here. So we have 2. Now, here the 2 has finished, but we have 2 here. They are not common. The 3, we go to the 3. 3, 1 is here, 1 is here. So times 3. Then 3, we can have another one here, matching with this one. That one too is 3. So these are the common factors. These are the common factors we have. So when we multiply them, 2 times 3 is 6. 6 3 is 18. So the HCF for 54 and 72 is also 18. So this is the highest common factor for 54 and 72 as well. Let's take another question. This involves 3 numbers, 12, 60, and 90. So we start with 12. And here we have 2 and 6. Here we have 2 and 3. Now 60, we can have 2 and 30. Here we can have 2 and 15. 2 cannot work, so we use 3. 3 and 5. Now 90. We have 2 and 45. So the next one, 2 cannot work, so we use 3 and 15. Yes, 3 and 15. Then we can have our 3 and 5. So the 12 gave us 2 times 2 times 3. The 60 gave us 2 times 2 times 3 times 5. Then the 90 also gave us 2 times 3 times 3 times 5. So this is what we have. Now we are going to select their common numbers. Now when you look through, 2 is here, 2 is here, 2 is here. So we can have 2. The second one is here, second one is here. But when you come here, the 2 is not there. So we cannot say they are common. Common means the same number should be found throughout. So now we quickly move to the 3. 3, 1 is here, 1 is here, then there's another one. So we can also use the 3. Now when you look here, there's 5 here, there's 5 here, there is no 5 here. So we can't say they are common. So we don't pick them. So when you look through, you can see that we are, yes, you can see we are done. So the common ones, we pick 2, we pick 3, 3, then 3. So this one will give us 6. So we can also say that the HCF, so the HCF for 12, 60, and 90 is 2 times 3, which is what? 6. So the HCF, the highest common factor, is 6. So this is how we find the highest common factor for 3 numbers. Let's take the last question on HCF. So here we have 180, 120, and 100. So the 180, we can use 2 and 90. We can use 2, 45. Then 2 cannot work here. We use 3, 15, 3, and 5. We have 120, 2, 60, 2, 30, 2, 15, then we have 3 and 5. 100, 250, 2 and 25. Yeah, we can use 2, we can use 3, 5 and 5. So 180 give us 2 times 2 times 3 times 3 times 5. Then 120 give us 2 times 2 times 2 times 3 times 5. Then 100 also give us 2 times 2 times 5 times 5. Now we are going to select the HCF. So we have 2, 2, then 2. So we write it 2, 2, another 2 there. So the 2 2's are common. We have 3 here, 3 here, there's no 3, so we can't say they are common. Now we move to the 5, 5, 5, then 5 times 5. So here 5, 2 is here, 1 is here, 1 is here. So only 1 is common, so we write it. So this one, 2 times 2, 4, 4, 5 is 20. So therefore we can conclude by saying the HCF for 180, 120, and 100 is 2 times 2 times 5, which is 20. So the HCF for 180, 120, and 100 is 20. So this brings us to the end of today's section, highest common factors. Follow this channel for more interesting mathematics topics. Till we meet again, we say bye-bye for now.